So number 6, state and explain the effect of changing pressure or volume has on equilibrium. Really what we're looking for in both cases is what's the change in pressure, because pressure is all about crowding. More pressure means more reactions on the crowded side. Keep in mind, this only affects the reaction if there's a gas on at least one side. One of the questions you had yesterday with opening the soda, it was aqueous CO2 on the left side, it's gaseous CO2 on the right side. So when you release the pressure by opening the can, that means the right side, that CO2 is escaping. A lot of you said the product escapes. That's true. The product escapes because the pressure was decreased. So that means more CO2 comes out of the soda. That's why your soda goes flat when you open it. So when we're talking about it, it's only if it's a gas. There has to be at least 1 mole of gas on one side. If there's more than one gas present, then you want to know which side has more moles of gas, which side is more crowded. Pressure really doesn't affect solids and liquids. So if you increase pressure, in both cases, whether you increase or decrease pressure, it's the more crowded side that feels the effect of it more. Okay, does that make sense? The more crowded side reactant Okay, so when you increase pressure, that's going to increase collisions. And it's going to increase collisions on both sides. Okay, so which way does your equilibrium move? It moves to the less crowded side. So when you increase pressure, don't tell me that the more crowded side, make sure you acknowledge that both sides are seeing an increase in collisions. It's just that the crowded side is going to see a bigger increase. So your equilibrium anybody guess what KC does? It doesn't change. That one's weird to me, why it doesn't change, because we didn't add any product or reactant. You're just going to have to trust me on it. I've seen explanations for it, and when I read the explanation, I'm like, okay, I can believe that. And then when I walk away and think about it, I'm like, I'm not sure I do believe that. But scientists agree it remains the same. So when you decrease pressure, then it's opposite day. You decrease collisions on both sides. But again, the more crowded side sees a bigger decrease because it's the more crowded side. So like if you're walking down the hallway, so let's say I have somebody walking, you're walking down this side, you're going to have a race. You're going to run down this side of the hallway at the same time somebody else is running down the parallel hallway back there. If I put 500 kids in this hallway for you to fight your way through, and I only put 50 kids over there, obviously they're going to get through easier. So now I decrease the number of kids. I say, okay, I'm going to cut it in half. If I take 250 kids out of here, that's going to make a much bigger difference to you than just taking 25 out of there. Because when you're more crowded, the change has a greater effect. So if I decrease collisions on both sides, but more on the more crowded side, when I'm decreasing it, I'm decreasing collisions. That means now the other side has more collisions. So equilibrium shifts toward the more crowded side. Because now suddenly I've had a bigger drop. It's like removing from that side. So adding and removing pressure is like increasing and decreasing pressure is like adding reactant to that side or removing reactant from that side, from the more crowded side. So if your product side's the more crowded side, when you increase pressure, it's like you added more because you increase collisions more there. And if you take pressure away, it's like taking away from your more crowded side. So yeah, it's the more crowded side that's going to see an increase or decrease, a greater increase or decrease. So both sides, collisions are going to decrease on both sides of the reaction. Because when you change the pressure, it's on the whole container. So people say, oh, well, you just increase, if you increase the pressure on the more crowded side, that will cause more collisions. You have to increase it on the whole container. So both sides are going to see, when you put more pressure on, the reactants are going to collide more, the products are going to collide more. But if the products were more crowded to begin with, they're going to collide to a greater degree and drive it left. Does that make sense though? But a greater decrease on the more crowded side. So increased collisions on both sides, but if I put greater increase on the more crowded side, and over here it's going to be a greater decrease. So the effect is greater on the more crowded side. And then volume, if you're changing volume, if you decrease volume, you've increased pressure, so then you go back to that. Increased pressure increases it more on the more crowded side. If you have more volume, you've decreased pressure, so the effect's greater on the more crowded side.